Dear students, in class 9th, under the topic coordinate geometry, you have studied how to plot a point on the coordinate plane. You studied about the coordinates of a point, the abscissa and the ordinate, and the quadrants. Today, in coordinate geometry, I am going to tell you a new thing, and that is the distance formula. Now, suppose there is a point P whose coordinates are x1, y1, and there is another point Q whose coordinates are x2, y2. And now you want the distance PQ. So the formula to find the distance PQ is equal to under root x1 minus x2 whole square plus y1 minus y2 whole square. The distance PQ will be equal to under root x1 minus x2 whole square plus y1 minus y2 whole square, and this is called the distance formula. Now it's very clear that whether you write x1 minus x2 or x2 minus x1, that doesn't matter because there is a square over there. Same for y1 minus y2 or y2 minus y2. Clear? But make sure that you subtract the x coordinate from the x coordinate of the 2 points and y coordinate from the y coordinate. Now first of all, I will give you a few examples how to apply this formula, and then I will tell you about the application of this formula. So the first question is find the distance between suppose the P point is 2, 3 and Q point is 4, 1. So you have to find the distance between P 2, 3 and Q 4, 1. So PQ is equal to under root. Now see, this is x1, y1, x2, y2. So x1 minus x2 means 2 minus 4. 2 minus 4 whole square plus y1 minus y2 3 minus 1 whole square. Now you know 2 minus 4 will be minus 2 and 3 minus 1 will be 2, and now minus 2 square will be 4 and 2 square will also be 4, so it is root 8, or you can say 2 root 2 units. That is the distance between P and Q. Now one more example. Find the distance between the first point P is minus 5, 7 and Q is minus 1, 3. So we have to find the distance between minus 5, 7 and minus 1, 3. Once again, PQ will be equal to under root. So this is x1, y1, x2, y2. So x1 minus x2. So minus 1 becomes plus 1. And then y1 minus y2 whole square. Okay. Now you see minus 5 plus 1 is minus 4. 7 minus 3, 4. Now minus 4 square is 16. 4 square is 16. So root 32. That is 4 root 2. Units is your answer. Clear? So this is how we can find the distance between P and Q. Now, the next question. Show that A 1,7, B 4,2, C minus 1, minus 1, and D minus 4, 4 are the vertices of a square. Show that these points are the vertices of a square. Now here is a use of distance formula. All of you first pay attention. This is A, B, C, D. The coordinates of A is 1, 7, B is 4, 2, C is minus 1, minus 1, and D is minus 4, 4. Now, although I have made it a square, but they are saying you have to prove that this is a square. So, if you, using the distance formula, if you find the length AB, then BC, then CD, and then DA, if you find the length of all the four sides, and if they are equal, all the four sides are equal to each other, then it can be a square or a rhombus also, because in a rhombus you know all the four sides are equal. So they are saying you have to prove that it is a square. So when the four sides are equal, now you have to find the length of the two diagonals using the distance formula. Find AC and BD. If the diagonals are equal, then it is proved that it is a square, because in a square you know the length of the diagonals are equal. And if the diagonals are not equal, then it will be a rhombus. That is the difference in rhombus and square. All the four sides are equal, both in rhombus and in square. But in a square, the diagonals are also equal, whereas in rhombus, diagonals are not equal. So first of all, I am going to find AB. AB is, this is x1, y1, x2, y2. So 1 minus 4 whole square plus 7 minus 2 whole square. Now 1 minus 4 will be minus 3. So minus 3 square. And 7 minus 2 is 5. 5 square. Now minus 3 square is 9. 5 square is 25. So it is root 34. You can see root 34 units is the length AB. Now we are going to find BC. That is under root 4 minus minus 1. so that is plus 1. 4 minus minus 1, that is plus 1, and plus 2 minus minus 1, that is plus 1. So 4 plus 1, 5 square, 2 plus 1, 3 square. Now 25 plus 9, once again you see it is coming out to be 34 units, root 34, square root of 34. Now we will find CD. Once again, minus 1 minus minus 4, so minus 1 plus 4 whole square, and minus 1 minus 4 whole square. Now minus 1 plus 4 will be 3 only, so 3 square. Minus 1 minus 4 is minus 5. Now 9 plus 25, and once again you see it is under root 34 units. So we have found that it is the CD is also root 34, and then we will find DA. Minus 4 minus 1 square plus 4 minus 7 square. Minus 4 minus 1 is minus 5, and 4 minus 7 is minus 3, like this. And now 25, once again it is root 34 units. So you can see we have proved that all the four sides of this quadrilateral are equal, but it can, I said it can be a rhombus also. So now the diagonals. So first of all we will find AC. That is 1 minus minus 1, so 1 plus 1. And 7 minus minus 1, 7 plus 1. Okay? 1 minus minus 1, that is 1 plus 1 whole square. And 7 minus minus 1, that is 7 plus 1 whole square. Now 1 plus 1, 2 square. 7 plus 1, 8 square. 4 plus 64. So it is root 68. So you can see we have found that length of AC is root 68. And now we will find the length of BD. Length of BD. We will find length of BD. So the BD is 4 minus minus 4, 4 plus 4, and 2 minus 4. Now 4 plus 4, 8 square, 2 minus 4, minus 2 square. 8 square is 64, minus 2 square is 4. So it is root 68 units. So you can see the two diagonals are equal. All the four sides are equal and the two diagonals are equal. That is the condition for a quadrilateral to be a square. So A, B, C, D is a square. Clear? Now the next question. if P having a coordinate x comma y is equidistant from equidistant from A 7 comma 1 and B 3 comma 5, then find a relation between x and y. Find the relation between x and y. Now see, the question is actually like this. This is P x comma y. This point is A 7 comma 1. This point is B 3 comma 5. And now they have given that PA is equal to PB. As P is equidistant from A and B, so PA is equal to PB. Now see, given PA is equal to PB means under root PA, that is x minus 7 whole square plus y minus 1 whole square, and PB is x minus 3 whole square plus y minus 5 whole square. Okay, we have applied the distance formula. Squaring both sides, the square roots will be removed. So we will have x minus 7 square plus y minus 1 square is equal to x minus 3 square plus y minus 5 square. Now here we will apply, in all these four we will apply the formula a minus b whole square. All of you know that a minus b whole square is a square plus b square minus 2ab. That is the identity. Clear? The identity is a minus b whole square is equal to a square plus b square minus 2ab. So when we apply it, x square plus 49 minus 14x plus y square plus 1 minus 2y is equal to x square plus 9 minus 6x plus y square plus 25 minus 10y. So we have applied the formula. Now you see this x square cancel and y square cancel. So here we have minus 14x minus 2y plus 50, 49 plus 1 minus 6x minus 10y 25 plus 9 plus 34. Now you bring minus 6x to this side. So minus 14 plus 6 will be minus 8x. Then you bring minus 10y to this side. So 10y minus 2y plus 8y. And shift 50 to that side. 34 minus 50 will be minus 16. Okay? Clear? So minus 8x plus 8y is equal to minus 16. Now you divide the whole thing by minus 8. Divide the whole equation by minus 8. So it will be minus 8x upon minus 8 plus 8y upon minus 8 is equal to minus 16 upon minus 8. Now see, this is x minus y is equal to 2, and that is your answer. That is the relation between x and y. X minus y is equal to 2 is the relation between x and y. So this lecture is mainly for your online test. It's a revision lecture. Later, I'll teach coordinate geometry in details. This portion you prepare well for your online test. Okay.